Well, hello and welcome to your last standards-based video series. We're going to look at Math 8 standards for geometry. And so this will be your last two-part video series. We've looked at 4th grade, 5th grade, 6th grade. We looked at 7th, and then this will be 8th. So we've looked at 5 grade levels and the progression of the geometry standards, and some we've even looked at measurement and data. But with 8th grade, we're strictly looking at 9 geometry standards. You can see these that are given. And we're going to look at different types of transformations. So transformations is kind of like this umbrella. And what falls under the umbrella, you're looking at rotations, reflections, translations, and we'll also look at dilations as well when you're multiplying or multiplying by a whole number or a fraction, which will increase the size of a given shape. Here you can see 8G.3, you're looking at the effects of dilations, translations, rotations, and reflections on two-dimensional figures. We'll also look at that in the coordinate plane. We'll also look at congruence and similarity. So here we're looking at in 8.G.2, we're looking at a two-dimensional figure is congruent if it goes through certain parts of different transformations like the rotations, reflections, and translations. Those are called rigid transformations. Think of the word rigid. It means it's not really changing its size. We're either moving it, we're rotating it, or we're reflecting it over an axis. And then 8.G.4, we're looking at similarity, which is different than congruence. Similarity means the same shape, different sizes. And that's what we'll get when we rotate, reflect, and translate and dilate. We'll also look at the exterior angle of triangles and that theorem, as well as what about the angles that are created when we have parallel lines cut by a transversal. We'll look at the proof of the Pythagorean theorem. We'll solve for unknown side lengths using the theorem. We can apply it to distance between points. And then finally, 8.G.9, we're looking at certain formulas. So we're going to look at cones, cylinders, and spheres. All right, getting into task number 1. So we're thinking of rigid motion again. So we're rotating it, or we're sliding it, or we're reflecting it. But notice that the shape here has not changed. Now this may be where we begin. Okay, so that would be our original. We would call it the pre-image. Now, how do I go from the pre-image to number 1? And that's what you're thinking about. You're thinking, what is, so from that, what's that movement? So that original, from the original to number 1 is a translation. Okay, that translation is a slide along some sort of vector line. So we can think, from here to here, I'm sliding it along some line, and that slide would be along a vector line, so therefore it would be a translation. Now this is not on a coordinate plane, so I'm not moving so much on the X or so much on the Y. I'm just thinking, how do I get this shape from point A to point B? And when it's not on a coordinate plane, then we're looking at it along a vector line. To go from the original to number 2, so think about, well, look at how it's compared. Okay, and back up here. So to go from here to number 2 would have to be, could be a series, could be a sequence of events. So you think about it, if we would slide this over here, we would have this shape here, but then we may have to reflect it so that you would see everything would rotate and fall on top of itself. Okay, so if I slide it, then I'm looking at something like this. Terrible drawing, I know. And then if I think about the reflecting of it, then that would think about trying to fold it over this line. Okay. So if I fold it over that line, it would land on what we see would be this line. All right, if I want to go from, so let me just state that. So for number 2 would be a sequence. It would be a translation and then a reflection. Now the order there doesn't quite matter because I could have reflected it over that line and then slide that into position on number 2. So you'll notice that some of your sequences, that the order will not necessarily matter. You could get there in 2 different ways. So now let's look at number 3. To get to this shape, there would have to be a translation and then a rotation of a certain amount of degrees. But in order for, because number 1 and number 2 look familiar to the pre-image because of where the red section in this drawing is facing. But then, so in number 1 and number 2 in the pre-image, the red section is facing to the left. But over here, the red section is facing down. So that means there had to be some sort of change in direction, which had to mean there was a rotation involved. Okay, let's look at task number 2, where we're looking at reflection symmetry. So when I say using a tool like a Mira, well, with the online class, and you print out your notes, there is something that you could purchase at the store, and it's just patty paper. The little thin paper that sometimes you can put between hamburger patties as well. You can get those at the store if you like. And those are great for the students to have so they can practice, and then they can rotate the patty paper or they can reflect it. They can also show how they can slide from point A to point B as well. Now, what I would suggest is you may not have either one of those, so how about a centimeter ruler? So if you're using a centimeter ruler, you're thinking, where can I draw a line to create symmetry? Well, if I go straight across horizontally in the Batman symbol, you're seeing that up here, that's not going to fold over that line and land anywhere here. So it doesn't have that horizontal symmetry that we're looking for. So if we think vertical symmetry, then now we're looking at somewhere where it needs to be somewhere right there. And I could draw that probably a little better, but that's what you would do, is you'd look for your ruler to where you would draw that vertical symmetry. So when you fold that over the vertical line, it would, everything on the left side land on everything on the right side. So we would say that this has one line of symmetry. All right, let's look at the second one. Here, we see that we have a triangle. And so when we think of lines of symmetry, we can think of the vertices, and that's plural for vertex. And so we have 3 sides, 3 angles. So if I drew a line vertical through the top vertice, then we would be able to fold this in onto that left side onto the right side and have symmetry. I can also look at drawing a line of symmetry this way. So then part 1 would fall onto part 2. I can also draw my line of symmetry this way, which would allow for part 3 to land on part 4. So this would actually have 3 lines of symmetry. Now notice how many, just notice how many vertices you had. You had 3. So what you've done is you've created the 3 lines of symmetry. Now that was a triangle. So notice we have here, we've got 1, 2, 3, 4, 5. So we can draw a line here and create the symmetry. We can draw the line here. So we have 1, 2, 3, 4, 5 vertices and 5 lines of symmetry. So if we have a regular polygon, in this case, this is a regular pentagon with understood all the sides being the same length, then we would have whatever number of vertices we would have is how many lines of symmetry. Now, for this next one, it's a little, maybe a little more difficult to explain online, but I think it would be a little easier with you when you have your printout. So when you have your class notes, you can print this out. And then here's what I would suggest. I would suggest that you get a certain distance away from point D and you just draw a vertical line. And then you take your centimeter ruler and measure. And I would measure each point to that line. And figure out the measurements. Okay, so let's just say that D was 1.5 centimeters. And segment A was 5 centimeters. And segment B is also 5 centimeters, and we'll say C is 4 centimeters. So if I'm going to create a reflection, yes, you can use a Mira tool. You can also use patty paper, but you can also use your centimeter ruler or your English ruler. You can use that straight edge to help you determine where this flag ABCD shape is, what it's going to look like on the other side. So if that was 1.5 inches or 1.5 centimeters, you're just kind of thinking, well, that's also 1.5 centimeters. And we'll say that's 5 centimeters and that's 4 centimeters, and this would be back to 5 centimeters. So what you would do is just plot your points. And what you would see is, and that's certainly not perfect because I don't have that measuring tool on my iPad right now to represent the perfect measurement, but that's what you're looking at. You're trying to create over to the side 5 centimeters. So that this measurement here, you're trying to replicate from over here. The measurement of segment C to the, we'll say line L, that's vertical, is 4 centimeters. Well, you're trying to recreate that same distance from line L to the right, and we would label that C prime. Up here, we would label that B prime. Notice I'm using the word prime at the end. Prime just means that there is a change from the pre-image to the image. So this would be A prime, and this would be D prime. So that distance here from the line L to the left, I need to see the same distance of 5 centimeters to A prime. I need to see the same distance of 4 centimeters to C prime. And I would need to see the same distance of 1.5 centimeters from that line to D prime. A similar idea here is to create that reflection. And with the Mira tool, it's really nice is you can kind of place that Mira tool along here and figure out by looking through it, how do you know where this would be drawn? Because what we're looking at is this is your original, the one on top. Notice it's A, B, C, D, E. So that quadrilateral or that pentagon shape, which is not regular, A, B, C, D, E, needs to be reflected over a line to create this new one, A prime, B prime, C prime, D prime, and E prime. Now to do that, you can figure out using a Mira tool, you could figure out where it is by placing the Mira tool on the black line. You can also use patty paper, but again, you can also use this distance from A to A prime ought to be the same. The distance from B to B prime should be the same. C to C prime from the line we'll call L to D should be the same distance as the line to D prime, as well as the line from E to E prime should be the same. So you could use a measuring tool to measure just the distances from the reflection line. Looking at our next task, we've got a sketch of a triangle, ABC, and we're trying to figure out, well, what sequence of rigid motion would allow us to map it to A prime, B prime, C prime. So I want to go from the yellow to the light blue in order to what we call map it. So I want ABC to land on top of A prime, B prime, C prime. Well, you need to also be mindful of your endpoints. So notice here's A, notice where I need it to be. I need it to be over here. So on the left, A's below. On the right, A's above. Here I've got C, which is above, and here's C, which is below. And then here I've got B below, and I've got B prime above. So we got to think about, I need those colors to match up. I need the green to land on the green, the purple and the purple, and the light blue and the light blue. So I need that to happen. So we think about our sequence of transformations. So method one could be that we just slide B to B prime on what we call vector B prime. So what we're looking at is we're just going to slide that from bottom left to top right. So we're looking at it going this direction. All right. And then once you do that, you would need to rotate triangle BAC to map onto triangle B prime, A prime, C prime. So we would slide it, but then we would rotate it. We would do that so C would land over here, A would land here, and B would turn and land here. So there'd be a rotation involved for method one. But then we have method two. And that would allow us to think, okay, so let's think about this again. Let's look at the colors and let's look at what's going to line up. And so I'm going to delete that segment there. Now another one would be just to reflect triangle BAC over a line. So you think about this line that I could create. I could create a line right here. If I create that line, then basically I'm taking C and I'm rotating, I'm reflecting it so it's over there. A is reflecting so it's over here. B is reflecting so it's over here. So you've got something that looks like that. Yeah, I could probably do that a little better. A is something here, B is something here. So this is what your triangle looks like. Well then, in order, notice that this would be C and this would be A and this would be B. I would need to do another reflection line because I would need C. Notice C would have to line up over here. And A would have to be here and B would have to be here. So we're looking at another type of reflection line that would have to go somewhere here in order to reflect it. So we would reflect it over the black line and then we would reflect it over the green line. So we would say reflect triangle ABC over a line, then reflect again in order to map triangle BAC to triangle B prime, A prime, C prime. Next question, we've got quadrilateral FOUR, which is right here. And so we want to map that to get to this shape, okay? So what we could do is we could draw a vector line from O to O prime. And so we could slide O down to O prime, but then there would have to be some sort of reflection. And so once you do slide it down to this point, then we would have to reflect for F to fall on F prime and U to fall on U prime, R to fall on R prime, but then O would land right on top of O prime. So we really would have to do a translation and then reflect over the line that actually passes through O and O prime. So that's one way to look at that. Or we can mix up the order and say we could reflect first and then slide or make the translation. So either one, out of order, there's two orders here. I can translate and then reflect, or I can reflect and then translate. And the same for PARC. So we've got quadrilateral PARC to the right, and I want it to land on top of P prime, A prime, R prime, C prime. All right, so we've got a couple of things we could do here. We could draw a line of reflection. We could draw it right here. And then we could figure out, well, what's that distance from the line to C? It better be the same distance to C prime. That distance from P better be the same distance from the line L to P prime. Line L to A better be the same distance as line L to A prime. Line L to R better be the same distance from line L to R prime. So we could use a ruler to measure that halfway mark, and then I drew line L, and then we could reflect over line L. Here we've got another example where we can do, notice it's that FOID, this quadrilateral, needs to become this quadrilateral. So in order to do that, we would want to slide that and make a translation along certain vectors. Okay. So notice, you can probably tell the different vectors that you would slide along. We would go from F to F prime, and go from O to O prime, I to I prime, and D to D prime. So once you just slide it along those vectors, you have actually created a new image, F prime, O prime, I prime, D prime, which your original was FOID. So in this practice, you actually have some different, several different methods with this. I want to give a sequence of rotations, translations, and/or reflections that will take this first one and lining up to this second one. And so if I'm going to label it PRQ, then I need to label it triangle ACB, and I have a misprint there. So C is my vertex that we're talking about. Notice I labeled it PRQ, so I'm going to label it I said PRQ, so I've got to label it ABC, and I think that's what I had originally. Yeah, that's what I had originally. So let's go from number 1 to number 2. Now, one way to do that, so we'll say method 1, is just reflect. Let's reflect triangle PQR over a line over, we'll say line M, but then I want you to translate 4 units down. Okay, so we're going to call two spots away from P, which would be right here. We're going to reflect PQR over that line, and then we're going to translate it 4 units down. So I've got my line off a little bit. We're going to reflect it over this line because, all right, why? Because that was 1 unit away and this is 1 unit away. So when we reflect P, we're reflecting it over here. When we reflect R, notice it's 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, that's where R is going to be. And then Q is 6, 7, 8, 9, 10, 11, 12. 6, 7, 8, 9, 10, 11, 12. So we are the equal distance from this line M that we're talking about. So that's one way. Reflect PQR over line M and then translate. Then we're going to move everything down 4 units. Okay. So let's look at method 2. We could say that we're just going to translate triangle PQR down 4 units, but then reflect over line M. So we would do the same thing, draw line M. And in this case, we're going to shift it down 1, 2, 3, 4 units, but then do the reflection in that sequence. And then let's look at method 3. Okay. And so method 3, we could translate or slide triangle PQR along vector PA. So now we're looking at, I could slide it this way along that vector. But then to do that, notice that, change my lines here, I would need you to reflect it over that dotted line. So we're sliding, like I said, we're sliding triangle PQR along vector PA. So we're moving the entire figure down to here, to here, to here. So this is the triangle that we have, and we've just shifted this way. And then what we would do is we would reflect it. And so now we're going to reflect this to where it lands over here. But what line was that? Well, that was reflecting over a certain line, and we'll call that line W. We had to reflect it over line W so that the purple would land on the green. All right, so let's switch gears and let's look at task 5, where we're going to take one shape. This is trapezoid ABCD. We're going to take that pre-image and we're going to apply 4 different transformations. So you can see on 1, we're going to reflect this over the y-axis, and then we're going to label it as a new image. So we're given trapezoid ABCD, where we're going to label it new as our new image, A prime, B prime, C prime, D prime. So it wants us to reflect. All right, so now we got to think, well, we've got 2 units from the y-axis to A. We've got 4 units from y-axis to B. So I'm going to go, I need to do the same thing. So 2 units, there's 4 units. So this is going to be A prime, and this will be B prime. And so D, notice D is going to be 7 units to the right. So I need to go 7 units to the right here. And so that's going to be D prime. And then C is also 7 units to the right, so it needs to be 7 units to the right here. So what we have here is your original, or your pre-image. And then notice over here, you've got your new image. So this would be C prime. We see B prime is associated here. C prime is, C prime maps 7 units to the left as C maps 7 units to the right. And then notice that D is 7 units away, D prime 7 units away, A is 2 units away, and A prime is 2 units away. So you have those same measurements. This is C prime. And then you can see that the orange shape is the new image, the yellow shape is the pre-image, and it was reflected over the y-axis. That's what it said. It said reflect over the y-axis. All right, so that's number 1. Number 2, we want to rotate. So we want to rotate this 90 degrees, but I also want you to rotate one that's 100 degrees. And we're only going to do this around the origin. All right, so to rotate it 90 degrees, we need to think a 90-degree angle. So this distance from the origin to A, I want you to look at this slope right here, okay? So from 0 to A, point A, is an increase of 1 and an increase of 2. So that slope is actually 1/2. Well, the reciprocal would be I need to go up 2 to the left 1. So I need to go up 2 from 0, up 2, but to the left 1. Now notice that these would make a right angle. Notice that I brought in these fractions here. 1/2 times -2. Well, the result is -1. And so when you know things, when you look at slopes of lines, if the product of the two slopes equal -1 and you're multiplying them, then we have our negative reciprocals of each other. So again, the slope from 0, the origin to from 0, 0 to A, that slope was 1/2. Well, from 0, 0 to A prime, it's got to be -2 to 1. So that creates point A here. Well, now we need to look at the same thing for B. I'm looking at the slope here to B. Well, that's going to be from 0, 0 to get to B. That's going to be a slope of increase of 4 to the right 4. Well, I want to do the same from the origin to B prime. I'm just going to go rise 4, left 4. And that's going to put me right here. So I get to connect these two lines here, those two segments. So this would be B prime, here's A prime. And now let's look at C prime. Well, C prime, or from C, it's going to be an increase of 4 and an up 4 to the right 7. That's the slope that I'm looking at right here. That slope of that line is an increase of 4 and increase of 7. So rise of 4, a run of 7, moving from the origin, that would land me on point C. Well, I need to do the same thing. So from 0, 0 to C, we said was up 4 to the right 7. So to go from 0, 0 to C prime, it's going to have to be up 7 to the left 4. So we can connect these two, and that would give me C prime. And now we can do the other one. We can certainly calculate the other one. We can also know that from A to D, right, it's 5 units. So I could just calculate the 5 units that are here and then put my point and then show that I've got my new shape. So that my new shape would be, it would have a rotation of 90 degrees. So it was in quadrant 1. The pre-image was in quadrant 1. Notice now it's been rotated 90 degrees. And I rotated it counterclockwise. I'll be specific in your example. I would say counterclockwise or clockwise from wherever you started. So just think about how an analog clock would rotate its hands, hour hand, minute hand. So counterclockwise, or you're dealing with clockwise. And then if I wanted to do one that's 180, all that means is I know that this shape's got to rotate one more 90 degrees. So to do that, that just means that whatever the slope was for A, if A was up 1 to the right 2, then that just means it's going to be down 1. So to get A prime just means it's going to be down 1 to the left 2. Well, those equal. -1 divided by -2 is the same as +1 divided by +2. So I'm going to move down 1 to the left 2. So there's my new point for A, we'll say double prime, because I'm creating a rotation of 180 degrees as well. So we've got A prime. And then B, we said was to up 4 to the right 4. So we're just going to go down 4 to the left 4. And there's going to be B prime, B double prime. So I can connect these two. And then C was up 4 to the right 7 to get to C here. So I just got to go down 4 to the left 7. And so see, there's C double prime. And then I know that D is going to be here to create the new trapezoid. So it's just a second rotation. That is a rotation of 180 degrees. So when we look at our pre-image to our first rotation and then a second rotation. So now let's look at what happens when we translate it. So I want to take trapezoid ABCD and I want to translate it 9 units left and 7 units down. So what this rule looks like is that I want to take it 9 units left. So whatever the X is, I want to shift it left 9, and then I want to shift it down 7. So I'm going to take whatever X is, I'm going to subtract it by 9. Whatever Y is, it's going to subtract it by 7 if I knew the coordinates. Okay, now I do know the coordinates. A would be 2, 1. B is 4, 4. C is 7, 4. And D is 7, 1. So I could use these ordered pairs here and then apply this rule. Okay, so to do that, to get my new points, I could just count from here, each of those points, or I can apply the rule. So what's 2 minus 7? Well, that's going to be negative 7. So I want to go to the left 7. And then what's 1 take away 7? Well, that's negative 6. So if I go to the left from 0, left 7, and down 6, that new point right there is going to correspond with A. So we're going to call that A prime. So everything should be pointing in the same direction. It just should be a slide. So let's look at B. B was 4, 4. Well, then let's apply the rule. 4 minus 9 is negative 5. So I'm going to go to the left 5, but then 4 take away 7 is negative 3. So I'm going to the left 5, negative 3, there's B prime. And we know D is 1, 2, 3, 4, 5 units away. 1, 2, 3, 4, 5 units away. And then C is only 3 units away. So this that would be how we would finish off this picture. But if you take 7, 4, what's 7 minus 9? Well, that's negative 2. 4 minus 7 is negative 3. So if I go to the left 2 and down 3, I land on C. D is 7, 1. So if I take 7 and subtract 9, I'm at negative 2. And Y take away, and so then if I take away 7, D was at 7, 1, right? And then if I go from here and apply the rule, 7 minus 9 is negative 2, but then I'm going to take 1, take away 7, it puts me down here at negative 6. So I have my new shape in black. So that's your slide. That's a translation. So all I have to do is take that pre-image, move it left 9, and then move it down 7, and I should land right on top of our new image. Finally, we want to look at a dilation. So if we want to dilate trapezoid ABCD by a scale factor of 1/2. All right, so I just need to know, again, what all of the ordered pairs are. And then what I'm going to do is have a scalar multiplier. So A is 2, 1, and B is 4, 4, and C is 7, 4, and D is 7, 1. So my multiplier is 1/2. So I just want to take half of all these X values, half of all these Y values, and then I will create a whole new set of ordered pairs that I can graph, and we'll see that the shape is much smaller. So let's start with from A to A prime. Okay, well, half of 2 is 1, half of 1 is 1/2. So if I move to the right 1 and up 1/2, that's my new A. So that's A prime. B, if I move to the right 4 and up 4, then B prime would have to be 2, 2. So I'd have to move to the right 2 and up 2. So there's my new B prime. So there's A to B prime. C, half of 7 is 3.5, half of 4 is 2. So I'm going to move, C is I'm going to move to the right 3.5, but up 2. So now I'm looking at that segment. D is 7, 1, so that would be up or to the right 3.5 and to the right 1/2 or up 1/2. So I'm going to move to the right 3.5 and then up 1/2 to create that. So now I've got this. What's in green is 1/2 the size of trapezoid ABCD. So we would say trapezoid A prime, B prime, C prime, and D prime in green is 1/2 of the size of trapezoid ABCD. So task number 6, we're going to look at where on number 1, it asks us to start at center O, which is here, and quadrilateral ABCD. Using a compass or ruler, I want you to dilate the figure from the center with the scale factor of R equals 2. So when you see R equals 2, it's considered that ratio is going to be, that ratio multiplier is going to be 2. So since it's a whole number, it's larger than 1, then that means that the scale factor of 2 makes the figure larger. If it was a scale factor of 1/2 or 1/4 or 1/3, it's going to make the figure small. So here's what I would suggest you do is take your ruler and from O to A, I would draw that segment, and I'm going to just copy that segment, and then I'm going to paste it. And what you're going to see is I'm just going to place it that same distance. So now what we have is A prime, but from O, it's doubled. So let's say that this measurement here from O to OA, let's say it was 4. Well, now what is it? It's 8. So we're just doubling that length. So you would do the same to B. You would draw from O to B, and then you're going to take that same, I'm copying it, and then I'm going to paste it. And so that segment is now double. So if OB was, let's say, 2 centimeters, let's just say all of these are in centimeters, then that means that your total here would be 4 centimeters. We're doubling it because the scale factor is 2. And then you're going to do that from O to D, and then O to C. So you're going to double those lengths. And then what you have are just your new endpoints. And when you have your new endpoints, then you're going to just connect and it's just a sketch here, but you should have your similar shape that you have as you have from the original. But you've just dilated it by a value of 2. Okay, then we're going to look at the next one. So the same task, but we're looking at part 2. And so what that's going to do is that's just going to have a scale factor of 1/2. So what I would ask you to do is take your ruler, your centimeter ruler, and I would ask you to measure from P to each of the vertices, okay, of the star. So each of the endpoints. Of the star. And I would ask you to measure that, and then I would say divide that measurement in half. So divide it by 2. And so you would do that for each measurement. And each measurement, you're going to find the halfway mark. And so I'm just kind of jumping ahead, and what you would see is you'd see that same star shape. Just a quick sketch here, but you'd see that same star shape down here. And that was not a good star shape, just a sketch. So it would look like something like that, where you would see that the star is much smaller than the original star because all of your distances were cut in half. So again, go from point P to each of your endpoints of the star. Measure it in centimeters, and once you find that measurement, you can draw a line like I did, or you can measure it and cut it in half, and then remeasure that new. So if it was 6 centimeters from here to this top one, then you know it's going to be 3 centimeters here. So then you would put your point, measure the 3 centimeters, put your point, and then do that for each of your endpoints of the star, and you would create your new star. So that's going to conclude part 1 of this video series with looking at translations and reflections, rotations, and dilations.